Okay, we are working on sections 4.1, and I'm going to finish a couple of the problems from the part 1 video that I do in class today, but there are a few people out of class. So I will just quickly, C is pretty easy, but D I wanted to take a look at. I would go ahead and FOIL out the top, and that's going to give you 6x squared, and 8x minus a 9x, so a minus x in the middle, a minus 12 at the end, all over x to the 1/2, just to rewrite that square root. Now what we want to do is use trick number 3, whoops, right there it was, where we separate the fractions, and that we did on this problem B. We're going to do the same scenario on this one. And anytime I have just a single term down the bottom, these become ones that I really love, because we can use this nice little trick of simplifying by going 6x squared over x to the 1/2 minus x over x to the 1/2 minus 12 over x to the 1/2 dx. And we're able to take this rational function up here and convert it into a nice polynomial function down here. Now let's just simplify one more step, and we'll have 6x to the 3/2 minus x to the 1/2, be positive, minus 12x to the negative 1/2 dx. Now for the integration. I'm going to think of each one of these individually, and I'm going to integrate each individual term. So I'll have 6x. Add 1 to this, which is like adding 2 over 2. It's going to bring me to 5/2. Divide by 5/2. Minus x to the 1/2, add 2 over 2, and I'm at x to the 3/2, divide by that new power 3/2. Minus 12, x to the negative 1/2, add 2 over 2, which is like adding 1. I would end up with x to the 1/2 power, divide by 1/2. Since we were integrating, we've got our general solution, which has a constant of c in it. Now, dividing by 5/2 is like multiplying by 2/5. And I'll do this step where I invert each of these fractions, flip them over, and turn them into multiplying. Now that we've got that step done, maybe just a little bit more simplifying, I'd have 12/5 x to the 5/2 minus 2/3 x to the 3/2 minus 24 x to the 1/2 plus c. This is my general solution. It is called a general solution because we have just a general constant added to the end. Soon we're going to find out how to get a specific solution if we know some initial conditions. And then one other problem I want to do from this problem set is letter E. This one, we've got a quotient going on, or a rational function, and I don't know of a way to integrate that straight up. There's no rule to follow. So what we're going to do is turn this hopefully into something that we recognize. In pre-calc, you learned some of these tricks when you worked with proofs of identities. And it kind of takes the similar like thinking on this to see, try to look forward and problem solve this one through. So what I did is I just separated the cosine on the bottom, and that will turn into, I can rename that sine over cosine as tangent, and I can name 1 over cosine as secant, the secant of x dx. Now, I don't know about you, but I recognize this right here as the derivative of a function that we've been working with. I'm going to try to page back and find the page here where it has all these derivatives and integrals. Make sure you make this correction. I see an n was deleted from that, and that needs to be in front for that derivative of x to the n. But as I look through my trigonometric rules, what I'm looking for is there a secant tan 1? right there. We struck it rich right there. The integral of secant tan becomes secant of x. And perhaps in your head you were saying, well, I knew that something had the derivative that was secant tan. The derivative of secant was secant tan. So now when we work backwards, we come up with the antiderivative of secant tan being secant. So let me page forward. This is simply now, the answer will be secant x plus some constant, and there is our solution. Letter F, I'll quickly get you started on this one. I'm going to have 5x to the 1/3 minus 2e to the x dx. And then you should be able to integrate each of these. This will be 5. You can try it. I will put my answer up here too. It's 1/3 plus 3/3 because I'm adding 1 to it. I will divide by that 4/3. Minus 2. The derivative of e to the x is e to the x, and that means then the integration of e to the x, the antiderivative, is e to the x. And so we've got plus some c. Flip this guy over, multiply by its reciprocal, and we will have our answer here real soon. Probably one last step, call it 15/4, x to the 4/3 minus 2e to the x plus c. So for people that were gone, that will help finish your notes. This is the homework. It's at the end of your homework packet.